It says we are live. Excellent. Hello there, world. We'll give everybody a minute or so to turn up. We had very minor technical challenges at the beginning, but I think we're now ready to talk about continuous integration. I see 4 or 5 people already streaming in, which is super stuff. And I will say hi to my good friend, co-author, former employee, and then boss, and lots of other things, Jeffrey. Hi there, and welcome to my live stream for the Squirrel Squadron.
Thanks, Squirrel. Great to be here.
Good stuff. All right. So I think we're getting people flowing in, which is wonderful. As you're appearing here, thanks for coming along to the Squirrel Squadron. If you don't know what the Squirrel Squadron is, I'll tell you in a moment. But the first and most important thing is, can you let us know in the chat, whichever platform you're on, where are you, who are you, and what brought you here? What questions might you have? These live streams are much better if we have lots of questions from you. And Jeffrey and I are very used to that because we've been doing talks together and 225 podcast episodes or something.
Yeah.
And we're always better with questions than we are with kind of cooked material. We have plenty to talk about today with continuous integration and releasing 50 times a day, but it'll be even better if you throw in some questions. So head to your chat, put in whatever you would like to know about us, and also tell us who you are, because we can't always see that. Hey, it's Tim. Excellent to see you. Right. So let me just say a couple housekeeping things. The first is this will be on a recording. So if you guys need to leave, or if in fact you're watching this on a recording, hello, thank you for being here. It'll always be on Facebook and LinkedIn and YouTube afterwards. They do a very nice job of recording for us. I should also say who the Squirrel Squadron is. So that's my community of fascinating tech and non-tech people. And we all get together here on events like this and on a forum. And we're actually going to be live in person on the 5th of May in London. And then I hope in Germany this summer to get together. And we all learn from each other. So what I see is that there are lots of tech communities and lots of non-tech communities. And then what there isn't is someplace where they can get together and exchange ideas. So that's what we do. And one of the things we're going to be doing today is talking about continuous integration. And I want to say hello to Malti as well. And I think Malti, I hope I'm saying your name right. And I think Malti is saying that really like both of your work. I think that's what it means. It says booth work, but I suspect that's a typo. Because I don't think I've worked in a booth, but I have worked with Jeffrey for a long time, and we do lots of stuff together. So glad to hear from you, and glad to have one of our fans here talking to us. Good stuff. So let me start by saying what I think continuous. There's 3 different things, and I never get them right, so I hope Jeffrey can correct me. What we're talking about. There's this idea of continuous integration, continuous delivery, and continuous deployment. And it's the last 2 I always mix up. So continuous integration is the radical idea that I first encountered in 1999. And Jeffrey, I think you hit it a bit earlier, and it became kind of mainstream in the mid-2000s. And that is the idea that maybe you could take all the software you have, you could make it all work together, and you could run some automated tests on it. And maybe that would tell you something about how good your software is way before you gave it to customers. And that's a radical enough idea. Then the part about releasing 50 times a day, which is what we put in the headline here, is continuous delivery and deployment. You're going to have to correct me, Jeffrey, if I get this wrong.
Continuous deployment.
Deployment is the one where as soon as you finish it, it hits live. And delivery is where there's a human in the loop. So there's somebody who says it's all ready. They push one button and off it goes to live. But both of them can produce very high cadence, very, very rapid changes to your production system. That's and right. really change the way your technology team works and the kinds of things you can imagine. They bring out. It's one of my favorite things about new technologies is they help you open your mind to things you would never thought of. Right. 20 years ago, I wouldn't have thought I could be on a video call with Jeffrey and loads of people around the world would be watching, but here we are. And now we can imagine that, and we can think of how to do it in an even more clever way. Continuous integration and delivery and deployment all give you more options, and we'll talk a lot about what those are. So, and hi, Tim, as well. Nice to see you. So we have 2 Tims. Glad to have both of you. And we have at least one question coming in, which is great. But Jeffrey, would you mind just introducing yourself and saying, how is it that you know about this stuff? And you knew about it before me, which I'm a little jealous of. Tell us more.
Sure. So I've been a long-time software person. I started back at a company called Borland in 1992. which I think is relevant because Borland was a developer tools company. So most of my career has been spent around developers and developer tooling. Over my career, I've done a lot of different things. I started off in support for the developer tools at Borland. From there, moved into QA, program management, managed the online communities, was part of the first JBuilder team there, so early Java IDE from Borland. Moved after that, went in roles in QA and then developer, and then was founder for a company in 1999, which is effectively GitHub, which Git
just a few years too early.
Yeah, GitHub didn't exist yet. Git didn't exist yet. Subversion didn't exist yet when we started. So we had CVS and other technologies, and I think at that time that's where I did a lot of thinking around continuous integration, because we had the idea of like, well, what happens if when you're working as a developer, you have the power of a server farm behind you? What are all the wonderful things you could do? And so we were thinking a lot about all the advantages that you could get from fast feedback in that kind of environment.
And of course, there was no cloud then, so it wasn't. If you wanted a server farm, you had to go to a physical data center and rack a bunch of servers.
Right, and although that was part of our business model, was we will have the servers for you, so you won't have to do that. Will be your development environment in the cloud. It was called Open Avenue, and our platform was called Oasis. So this will be your developer oasis to get yourself up and running quickly. When that company died a .com funding death. It was not itself a .com company, but the 2001 crash took out many of us. In 2000, rather in 2000 crash, the 2001 we finally that kind of wound down, and I was still excited about this idea, and I got 2 different job offers, both doing the same thing, which was to create effectively what today would call a CI system. And I chose, which
didn't exist either. While we're saying all the things that, back in the Stone Age, we were actually just banging the code in using cuneiform tablets. You couldn't just go and get something like Circle CI or Hudson or something like that. Those had not been invented yet.
Right, exactly. Although when I took on that job, then what I first did was see, well, what else is out there, what's available. And I did find Cruise Control Java, which was one of probably the earliest open source CI tools, although very different from the ones from today. So I started working on that in 2001 and became a submitter to the project, and then became a committer. And then about 5 years later, 2006, the project was brand new, basically, when I got involved. One of the project founders, Paul Julius, invited me to help host a conference, which originally was going to be the birthday of Cruise Control. But then someone said, well, why limit it to Cruise Control? You're not a vendor. You don't really care. So we made it, instead of being a birthday party for Cruise Control, we made it the Continuous Integration and Testing Conference, and invited a broad swath of people out there who were talking about CI. Because in that time period, all of the practices that people think about now for continuous integration for testing, there was a lot of ferment in the development world about figuring these things out. So KitCon still goes on today.
This conference, continues today, and I've just put the link on the screen. So if you're interested, I think there's one this summer. We hope, Jeffrey.
We plan on doing one, at least one, maybe 2 this year. We'll do one in Europe and possibly also the US. And I just was talking to another KitCon alumni not long ago, and he was quite keen to help us happen in the US. So we'll probably have it in both places this year. And so it continues. And that's what, so for me, continuous integration and the side of things like it have been much on my mind since 99, and with real work both in my startup and then at Cruise Control, and then being part of this community, which is where you and I met originally in 2006 at
Absolutely. KitCon. Yeah, very glad that we did as well. So one thing I want to cover here is we've been talking about these very early days of continuous integration. And one idea that stuck around but has never taken off. It's the kind of it's the smallest possible continuous integration server, and it's the one that requires the least installation, but is also least popular. Mm-hmm. And that is, of course, the rubber chicken.
Yeah.
And I'm just wondering if you could describe, because for people who don't really know what this is, you might hear your tech team talking about it. There's some people in the chat I can see who know all about it. That's great. Hang on, we're going to get to more stuff later. But this example actually is really helpful to get a common language for everybody.
Yeah.
So Jeffrey, how do you do continuous integration with a rubber chicken?
Right. So continuous integration as a phrase did not originally talk about tooling at all. So the phrase became popular with extreme programming. And in extreme programming, what they were talking about was, we should all be working on the same code base all the time. We should, as we make changes, we should check them in and handle all the merges as we go. And again, this is late 90s. And it was in contrast to what was the normal practice at the time, which is developers would have a lot of code on their own desktop. Even if they did check in, there was no idea that it actually should build, because you had a separate development phase followed by an integration phase. And that was manifestly terrible. Like projects would die in integration, because after people would spend 9 months developing code without really concern of did it all work together, then the answer at the end was, well, no, of course it doesn't work together. And so that integration phase, there was months and months of effort would go into trying to make the whole system work. And that it was the problem that people were trying to solve. And they've been trying to solve it even through some amount of automation before that. I think one of the famous practices about Windows NT was they had a daily build and smoke test. So they would, now they weren't necessarily integrating everything all the time, but they would have integration branches and they would push things in, and every night they would build the code. And there was the expectation then that what had been pushed and merged should compile, it should work. And again, today that seems odd. Well, of course it should work. But I will tell you, when I was at Borland in the mid 90s, yeah. I remember I was trying to build the source code locally, and I went to the developer who checked in the commit. I said, like, I noticed you did this commit, and it now it doesn't compile. And they're like, well, yeah, but we're in development now.
Yeah, who cares?
Who cares? Like they were really almost offended that I was wasting their time, that I would come to their office, because in their mind they're the only developer for this code, and they're not done yet. So
who would care whether it works together or not?
Yeah. Yep. And to me, even this is the first software project I was really involved with. That just seemed obviously wrong to me. So I never really got indoctrinated into that way of working. It always seemed wrong to me. I always want to know about things are working as soon as possible. So continuous integration as a development practice, like we should be committing frequently, we should be handling and paying the cost of merge as we go, always felt instinctively right to me. And then when that was in the book in the XP book, XP Explained, the white book from Ken Beck, or even earlier when it was written up about extreme programming and Words Wiki in '99, I thought this makes a lot of sense. And I was interested in the build tool aspect of it, not as a replacement for that, but as a way of assisting people. So, you should be going ahead and merging the code and making sure it works locally. And then can't we maybe also help you find things that you couldn't have found otherwise? And I was inspired by a project at Mozilla called Tinderbox. And Tinderbox was a system that they used because they had a lot of different architectures. So, they support, I can't remember, something like 21 different architectures, SGI and all that for their browser. And you couldn't reasonably expect a developer to make sure that their C++ code compiled across all 21 platforms. So Tinderbox was their solution. It was a build loop that was running on each platform, continuously compiling. It would notify anyone if something broke. It would say, look at the people who committed differences and tell them, hey, look, the build broke, and it's one of the three of you. So go figure it out.
Yep. I remember this. That's where I encountered it in '99 in a much smaller company that I was in that needed to operate on a bunch of platforms and had a server farm in a data center. Yep. And you push buttons and made it go, and then got errors back. And that was very exciting at the time.
Yeah. And I thought,
but I don't think did we get to the rubber chicken?
No. So the rubber chicken this is a manual practice that you should be doing. And
even if you don't have a server, it's like the world's simplest CI server.
You don't need a server, right? So the idea is that in extreme programming, there's different groups and pairs. When the pair is ready, their idea is originally was that you went to the special integration machine and you integrate your code there. But James Shore had the alternative locking mechanism, which is you just take the check-in token, which in his case was a rubber chicken. So whoever has the rubber chicken, you can't commit your code without
not
the
a
rubber
chicken, but here's a toy. You get a thing. Here's the hungry caterpillar, so you could use this. The trick is there's one of it.
There's one, exactly.
This is hard to replicate. It's not like there's going to be two of them floating around the office.
That's right. Back when we were all in offices together. So
yes.
the assumption here, and I think this is actually a good point. The assumption XP was that you were in a co-located team. And so the idea of using a physical lock to make sure that only one pair was committed at a time was very useful. Now, in my startup, our assumption was that we were dealing with distributed development. The whole model we had was that in the future, all development will be distributed development, and open source is already distributed. And so we'll probably be using something like the open source process. And so our framing was, because you can't, not in the same office, you can't grab the chicken. Well, then what can you do is people will be submitting things at different times, but we can be pre-checking those submissions to see if they work. And so think if I'm an open source maintainer and I have all these people submitting patches to me, well, help me out. Let me know which of the patches actually build and which ones pass the tests before I spend time integrating them.
And
so that was
the
kind
advantage
of
of all of this is that you have continuously deployable code. So if you're using the rubber chicken method or the server method or the modern servers that pretty much every development team I encounter have, then in every case you can say my code will compile, that I'll actually be able to make something. I'll be able to make software. And I can run the software and I can run some tests on it that verify it has certain characteristics. And that's huge, because in your Borland days and in my early days, we didn't have that. Your friend in the office didn't know whether his code worked at all. He just had no concept whether it would work. And he certainly couldn't deploy it to someone to actually use it. And that's where we get to the 50 releases a day. That's
right. And I'll just say it was interesting for me that when Cruise Control came out, that I always thought, well, great, a team will go install this and they'll all know when things are breaking. And I did see that, but I also found interesting cases where people would run it for themselves locally, and they would run their local build, they would run their own tests, and then they would go to the other people in their team and say, hey, Mike, that thing you just did, it broke these tests, can you go ahead and fix it? And one of my friends was doing that, and he said after several weeks, someone said, how do you know? Like, how is it you always know when this stuff is broken?
Psychic, that I broke something before
I just did this. How could you find it? It's like, well, I have this system running, and then I said, oh, that's great. We should run that for everyone. It's like, good.
That's how it spread. So it became a very popular idea. And now what I see, and it kind of breaks my heart, and I don't know if it does for you, Jeffrey, but I evaluate teams for due diligence and health checks and things. And so I'm seeing a lot of teams and all of my clients, and everyone has a CI server. It's just absolutely de rigueur. I think I haven't seen a team that doesn't run any kind of continuous integration in many years. Yeah. But a lot of them aren't getting the benefits.
That's right.
So all these things we've just talked about, they have this thing kind of running in the corner, and they get a little benefit that they do know their code works. So they do have the idea that actually we can put it together. It's not that I checked something in that deletes the entire database or something like that. So that's a step forward.
Yeah.
But they're not getting tons of the benefits, which really drives me bananas. And that's why I wanted to have this stream with you.
Yeah.
And make sure people heard this is the sort of thing you can get. This is where you can be.
Yeah. Well, the first thing when I hear you say that, I'm thinking branches or pull requests.
Well, that's part of it for sure.
Yeah.
We're going to come to
integration.
That. Yeah. Yeah. We're going to come to that. I wanted to have a great quote from PJ, Paul Julius, your partner on continuous on KitCon. But before we come to that, let me come to this, which is that there was a huge seismic event. I remember reading this article and just thinking that it had to be made up. It couldn't possibly be true, even though I'd been using CI servers for a while and I hadn't realized this possible benefit. And it was from a company called IMVU. Mm-hmm. And it was all about how they were releasing 50 times a day. It was called Doing the Impossible 50 times a day.
That's right.
And they had moved not only to continuous integration, where the code would actually be brought together and verified, but actually to the point where they believed their tests enough that as soon as you finished some code, it went live. There were no humans in the loop. Yeah. There was nothing happening there. And many people get this benefit by having a human who's there who rapidly pushes the button. You can get both.
Yeah.
but they would go live with changes to code and then monitor the system live. What they did was they were building a marketplace where people were using avatars to chat or something. I don't remember. But if suddenly all the avatars turned purple, their monitoring would notice that like everybody logged off. I don't like being purple. I'm going away. And they'd say, oh, user numbers plummeted, automatically revert. And then the numbers would go back up and off they would go. Now, there's different levels of suitability for this, and whether 50 releases a day is meaningful for you can depend on what you do. If you're building nuclear plants, please don't do that. That's probably not a good idea, because the equivalent of avatars being purple could be meltdown. So let's not do that. But even at I had a biotech client, that was building software that if it malfunctioned would cause people to cut off parts of their bodies because they got the wrong genomic information. And so it kind of mattered if they got it wrong. It was really, really important. But they were releasing every 6 months. All the CI tools, everything, they kind of knew internally what was happening. But the releases were every 6 months. By using a lot of these methods, by doing the sorts of things that got them going faster, they could get to every 2 weeks, which is revolutionary in biotech terms. The idea that you could change something that had this much medical importance every 2 weeks for them was the equivalent of, many of you might have said, 50 times a day, I don't believe it.
Yeah. But,
so Jeffrey, what did you think when this article came out? And we'll say more about how it works, but what was your reaction when it first appeared?
Well, at first thought was this fantastic, but I wouldn't say that because one thing about your genomics, because these are impressive technical feats, but the real value is the business impact.
Absolutely.
And you talked about that. It was revolutionary for them as a biotech firm, not just in technically, but what the business impact would be. And the same thing at IMView. And I, because I want to come back to that, IMView was also the source of lean startup. So people who know Eric
Ries tried it all out.
Exactly. So the reason for this business. So I read it. I'm like, fantastic. Well, and I thought it was great because at the time, we in the KidCon type community were talking about, we had been saying, look, we keep bringing more and more stuff into our CI server. Because once you have it there, once you have the power of like, great, I know it compiled. What else could I know? Oh, I ran my unit tests. Well, what else can I do? Oh, guess what? If that passes, I can go and put it out on a test server, and I can run my Selenium tests, and I can know it works in the browser. What else
if it
can
works
I
for
do?
Selenium, so I can check it in the browser. A human could go and look at it, and they could try it out. Our staff, our internal people could try it.
Yeah. So we kept building onto the pipeline that we call it today, and doing more and more. And it got to the point of saying, well, and maybe we can just deploy it. And we were talking about the phrase end-to-end continuous integration, and going both ways. We might say, look, maybe we can be running lint here. Maybe we can be running static analysis tools that will find security holes. So we can bring more things in early in the cycle, as well as taking more things downstream. Can we plug more and more of this together? And that was the phrase we were using, end-to-end continuous integration. And then this article came out. It's like, yep, there you go. That's what they're doing.
Deploy. Yep.
And what struck me about it was, it was a bit of a breakthrough for me in two ways, because it really integrated a lot of ideas that I had seen separately, but hadn't seen glued together in quite this way. Because one of the things was, when we talk about it, when you check in, we should say what happened is, if your check-in didn't compile, it was just reverted. Like that, it's like, nope. That doesn't compile. Like that's not going anywhere.
It doesn't get to stay in there, and we're going to come back to this when we get to branching. It doesn't get to stay in there, and other developers build on top of it, and then you get into a mess at a car crash where everything's built on top of broken stuff.
It's gone.
It's gone.
If your unit tests don't pass, it's gone.
Yep.
Yeah, it's just reverted. I was like, wow, okay. They would then go to their integration tests, and they had set up a server farm to run all of their browser-based tests in parallel, and that would take, I think, less than 15 minutes was their goal. And again, if it broke any of those tests, it's reverted. So it's just sort of the discipline of, we expect the software to work. It must be working at all times. If you check in something that's not working, it's reverted.
And then an even further step that they took, which the one that really blew my mind, was, of course, they would put it live. And then, as I was saying before, they would monitor to see what usage numbers were, whether people were paying.
That's right. They call this the cluster immune system.
Yeah.
And I think the key thing here in the cluster immune system, they would put it out to a portion of their servers, so maybe 10% of their users. They would put it out in one of the clusters, and then they would monitor the business metrics. I think this is the key thing. It wasn't like they were doing more tests there. It's like, no, now it's live. and we're going to look at the business impact of the change. And if the business metrics go down, if the number of dollars we're making per minute drop, then we don't revert it. No, we don't revert it. We don't.
You don't get rid of the code, but you do take it out of the.
But we take it out of the production and we freeze it, and then that host that has, or that whatever set of hosts that have that version, we're going to hold on to that so we can go investigate what happened, what's going on that it dropped. So
because maybe we made the change we intended to. It compiled, it passed all the tests. We thought it was great, and users hated it. We were going to change all. It was 4th of July, and we were going to change all the avatars to be red, white, and blue for America's birthday. And sorry, users hate that. Most of our users are in China, and they're not a fan.
Yeah.
So if you discover that, there's actually a business problem, you can jump on that straight away. And I think that's just such a huge advantage that almost nobody uses.
That's
because even if they're using something that's close to continuous deployment, they might be doing continuous delivery where there's a human in the loop. They're often pushing the button only after great ceremony, great activity, and then they don't monitor the business metrics.
That's right.
So they get lots of checking up front and not the really beneficial checks, which are in live of the business metrics. So here's the first thing. Tim was asking about this. I think he was saying, I kind of understand the CI stuff, but how do you do this 50 times a day? The first thing is reduce the amount of human effort on the front end. Do a lot of automated effort. Get as much as you can before you go live. Then after the live moment, monitor the business metrics. See what's actually happening. I read that Etsy, the people who have the marketplace for people make handmade dolls and other things, handmade stuff. They actually had a real credit card that would, and they had a real user of the system, and they had programmed it so that every hour it would buy another thing, just randomly chosen from one of their many people who made stuff. And then it would be shipped to their office and then given away to charity. So they had a room full of these things. And of course, if they ever didn't get any, if they discovered that the bot tried to order and couldn't order, that was an immediate red flag. So they would know that something had gone wrong. And because they're doing it fully end to end there, of course, they were also, I'm sure, monitoring actual credit card purchases, and those would drop, they would notice. But this one could tell them, well, I did this and this and this, and it broke at exactly this stage. In real live production, which could be a problem with the credit card provider, but who cares? You're not selling things. If you're not selling things, Etsy dies, right? So you'd want to know that very quickly. So you don't have to go that far and spend money with your clients and actually become a user of your system, but you can do an awful lot to test once the system is live. So that's, I think, our first lesson of the day after the history lesson, which is monitor your business metrics and go live an awful lot more often. And in almost every case, other than say the nuclear plant, where that might have worse effects than you want, in almost every case, including my genomics case, you can do an awful lot more with that than you think you can.
Yep. And I think this is the key thing here, because I think that I said it brought together a few things that I had seen separately but not together. One of them was that sort of automatic revert, and then the other one was this monitoring, this emphasis on monitoring, because I think monitoring is often one of those things that is left insufficiently explored. Like we don't really exploit the power of it, because what would happen is if they had this case where the business metrics went down, like that's an incident. Like they need to go understand it and investigate it as a high priority incident, and that's just not the way most people think about it. If something, even if something does happen in production, then the most likely thing is like, let's get production working again. Like that's the priority. For them, that was an automated step, right? So they weren't rushing to get production working. They would just revert that the traffic to go to the ones that were known working before. So there was their emphasis was not spent then in trying to get things working again. It was to learn, and so that enablement of more valuable learning, I think, was one of the things that really stood out to me.
In a very rapid loop. If you do something 50 times a day, you almost have to get better at it. It'd be very hard to do something 50 times a day without improving. And
I'll say that because one of the things they started, I'll say this is actually really key, is they started by doing the same process, but manually. Mm-hmm. So they started with no tooling. It wasn't like they, went
back to the rubber chicken
system. Yeah. They started with the equivalent of a rubber chicken. They started with just people, and it's like, okay, you have to change. You need to push it live. You need to deploy. You need to monitor it, make sure it's working. And then, but they also had the ethos that every time that you do this, you should invest a bit to make it faster for next time. So
and then over time, again, if you're doing it many, many times, even a
Yes.
small improvement every time gets you much better quickly.
That's right.
I want to come to a viewer question. So this is Sanjeev, good friend of the community. We see you all the time. I hate these because I always have to sit up, so I will sit up. Hi, everybody. Now you can see me. Sanjeev asks, rapid changes sound great, but how do you rapidly roll back changes when things go wrong? So we've mentioned a bit about that, but just to elaborate on it, the kind of system that these folks and lots of others, they're certainly not alone. They happen to be one of the first to publicize it, but I've seen very, very solid teams do this over and over again. What you have is a mechanism by which, first of all, if it hasn't gone live, you just revert in your source control system. So you have a source control system like Git, that's the most common one these days. And in there you can say, hey, this change, we didn't really mean it, take it away. Now we're going to come to something called branching, and that can cause some problems with this, which is why we'll discuss how branching might work with this or not. But whichever way you're doing it, if you do enough, you can go into some code that has just been changed, and you know about it, and you know it failed, and then you can revert it. That's the automated reversion internally. And then what they were doing live is to actually roll out only to a few servers, only to some of their customers, and then just to isolate those. So just to say, okay, this will continue to run, but it won't take any more customer traffic. The customer traffic will go to other nodes in our network, and they will run the old system, and it will work just fine.
I think the key.
Go ahead.
I'll say the key thing here, though, is just be clear, is that you're going to have your design and architecture in a way that supports this. So, and I think it's an important mental shift. So it's not a case of saying we have this architecture. How do we make it something we can roll back easily? Or how do we roll it back easily? It's like we have our current architecture. We need it to roll back. So what changes do we make to enable rollback? I think, for
example, you might run on just a small number of servers and you need more, and that means more cost. But if you tell the CFO, I'm going to release code 50 times a day, or even 5, or even 1, and therefore we're going to go faster, suddenly money seems easier to get. That's what I usually find.
Yeah.
So having more servers might be one way that you would get to this point where you could segregate them and say, these are the ones that are bad at the moment, and these are the ones that are still working. Let's turn these ones off and run these. Just to mention 2 other things. One is that I love the language PHP for many reasons. This is an unpopular opinion. The developers, many of them are cringing, I suspect. But one of the things I love about it is it can give you a more or less instant rollback. To speak technically for a moment, you can do an atomic change of directory, so you can change a symlink, and the result is that you're running the old code. So we used to do that all the time, and not with necessarily very much automation again, but we did this in a e-commerce business that I was CTO for, and we would wait until the customer service people screamed and they'd, oh my God, it's down, oh, nobody can buy, it's all terrible, and then we'd hit a big red button, and that would do this instant reversion. And then we'd say, what are you talking about? It's fine. And they'd say, oh, now it's fine. What did you do? We said, we hit the button. So you can do this kind of reversion in a very low tech way, and a very simple way if you have the right setup. And Tim McKinnon notes that, hey, look, you can snapshot code and data in the cloud. There are all kinds of clever tricks which would allow you very easily to do this kind of thing. So it's not a huge technical challenge to do these days. It's pretty well known. The problem is people don't do it. And I think one of the reasons is they don't know it's possible and they don't know what the benefits are. So that's what we're trying to fix today.
I think
so. Sanjeev, I hope that helped with your question.
On the benefit side, I think is the real drawback, because I think there's kind of a bias towards the norm. Like, well, this is what we've always done. This is what other people do. Like, what's the big deal? And so they don't. If you really wanted the benefits, you'd figure it out. So it's a question of getting people hungry for those benefits.
And that's what we're trying to illustrate for you here. Tim asks a very good question. So he says, he wants some inspiration for 50 times a day. Hope we're moving in that direction for you, Tim. And also how to do it in scale. What do you do about schema migration? So that's, of course, one of the tricky challenges. And what Tim means there, for those who might not be as technical, is you have your data stored a certain way, and now you want to change it. You used to have first name. Now you want to have first name and middle name. And maybe you're going to take some people who are named John Paul, and you're going to make them John Paul in 2 separate places. And doing that kind of change really plays havoc with the servers. You can't just say, okay, well, this one knows about John and this one knows about John Paul, and suddenly they're going to play nicely together. John tries to log into both, and different times he gets different results. So Jeffrey, what have you seen as ways of working around the kind of deeper changes that might need more care?
I think normally it's a case of taking one of those big scary changes and breaking it up into small, not scary changes.
Exactly.
So in the case of Jean-Paul, it's like, well, what you typically do is you're going to say, okay, we have our current state, we have our end state. You currently have the name field as one thing, we want it to be two.
Yep.
So what we'll do is we're going to, rather than make that step all at once, we're going to add the two new fields. Yep. And guess what?
Go up here, and we keep the old one.
And we keep the old one.
Yep.
So all the code's still working. And then we go and make sure that all the, that we changed all the data is now in both places. And then we're going to change it. So when we're on the right side, when we write the data, we'll write it to both, but we're still reading from the old one. And then you can go and change it. So you're reading from the new location, and then you go and remove that, the old location, and so you do a migration, and every single step is safe along the way. And you take what was like, oh, but this change will break things. It's like, well, just break it up into a set of non-breaking changes. And that's the general pattern for doing this type of thing.
Absolutely. Absolutely. And the other thing to note is that there are certainly some kinds of changes that if you work hard enough, you can find one that really, really does require actual system downtime, and that really requires something to completely shift. You can't do these tricks with moving the servers around and turning some off and some on and reverting things and isolating. But that's okay, because those are extremely rare. And you usually know about them way in advance. And so you plan, all right, fine, we're going to be down for an hour on Saturday, and you go back to the old way. But that's something you do very rarely. The much more common change is, hey, I'd like this button to be on the left, and I want to see if people click it more. Or I would like to be able to handle people named Jean-Paul, and I'd like to be able to talk to them, but I don't really care whether it's first name and last name, or first name and middle name. I just want a way to be able to track them. And if they call John or Jean-Paul, they still are the same. And the kinds of tricks Jeffrey is describing really help with that, so that you can keep running the whole time and get business value very quickly. So, Tim, I hope that's helpful with that question. Please ask more if you'd like to. Jeffrey, there's a topic I want to make sure we get to. This is flying by. I'm having lots of fun talking to you, as I always do. But our mutual friend, PJ, Paul Julius, we mentioned him before, one of the fathers, parents of cruise control, likes to say, he likes to ask people, so how are you getting your code live? And they'll say, oh, yes, we use the Git flow pattern. We merge here and we create a feature branch and so on. He says, yeah, I'm looking forward to hearing about when you're actually using continuous integration.
Yeah.
So could you explain what his comment there? Why is merging and branching and all these clever things people do not so compatible with this idea of continuously integrating hint, your code?
Yeah. So I think I would make a comparison to back to the way things were in the 90s, right? So people would often in the 90s pull out changes locally, and a developer would work on their desktop for, days, weeks, months, just
called it checking out. You would check it out like a book from a library. You would have it physically, and it would be yours, and no one else could touch it.
Yeah. And if that was the case, it wouldn't be so bad. But then actually what happened is people said, oh, but you've been working this for 3 weeks, and I need to change one of the files. Rather than having that checkout model, let's make sure we can work concurrently. And this is where we get something like CVS, the concurrent version system.
Yeah.
And so now we can both work on the same code at the same time. And that's really helpful in many ways.
Now, also extremely dangerous.
The problem is it's inevitable that people will, working the same files, will end up making incompatible changes.
You change this, I change it to something else, and suddenly, bang, what do we do? And this is, if you've heard your developers talking about merge conflicts, that's what they mean.
Yeah, and that's fine. It's like two people editing a slide presentation at the same time, but they're, on each other local copy of PowerPoint, and that makes it really awkward. Well, how do you solve that with PowerPoint? You go to a system like Google Slides, or you're using SharePoint, and you have people editing the same copy of the slides at the same time. And so you can see each other's changes and know when you're trying to do things incompatibly. Great. That's continuous integration, right? When you do that on Google Slides, you're now doing CI. You're integrating your changes together at the same time, and they're visible to everyone. Unfortunately, in the same way that a lot of people make this mistake, I think, with PowerPoint slides, and they are all editing different versions and who has what, and things get broken. The instinct people have is, well, I don't want to I'm afraid I don't want to break what other people are doing. I don't want to trouble other people while I'm working on this. So I'm going to try to keep my stuff separate. And that went from kind of a manual practice of I'm just keeping it locally. I haven't given it to anyone else. Then they said, well, no, we want to have it on the server, but we'll make it so it doesn't interfere with the real code. So that you have this idea of like there's the trunk, there's the main flow of the code base, but rather than committing to that main flow, I'll create a branch. I'll
like
have my own little
branch line of a railway.
Yeah, exactly. Yeah.
Here's the main line, and then it branches off to go to a smaller station. Yep.
Yeah. Or the branch of a tree. It's sort of like, here's this other side thing. I'm gonna check it in a branch for now while I'm doing my work, because I don't want to interfere with other people. And so it's like this good motivation. I don't want to interfere with other people. But the problem is that what you're doing now is effectively the same as if you kept it locally. You're not actually integrating. You're not bringing the code together.
And it's not continuous integration where at all times, your code will work with mine, will work with Jeffrey's, will work with everyone's.
Right. And that's the point. The continuous integration is like there's one set of code. We're all working from the same code. We're all working from the same place. And I think this is just a deeply unintuitive way. And I can see this because people keep reinventing ways to defer integration. They stash local changes. They create branches. They come up with pull request systems, where there's a delay between when someone does the work to change the code and when it actually gets merged in with everyone else. And that's the danger zone. And people keep reinventing these delays. And that's the idea is that you need to remove those if you really want to be doing continuous integration.
And then get all these benefits we're talking about, like releasing so frequently and so on. You're not going to get those if somebody takes code, takes it off to the side, goes down the branch line, and then suddenly gets way out of sync with everyone else's, and then has to be very carefully merged back and corrected and fixed. And then finally, 3 days later, it can be released. That's not continuous. That's not 50 times a day. That's not even once every 2 weeks. That's going to be very slow and painful.
And my experience is that people who've resisted this, when they've actually tried it, and once they've had the experience, they're like, oh no, I was wrong. This is better.
Yep. So you may have to force people kicking and screaming, or give them carrots and lots of cookies to try it. But it has a fancy name, by the way, and I'm very sad about this name. I wish this name didn't exist because I just call it development. This is how you should develop code. But it is commonly known as now as trunk-based development. In other words, you always have the trunk.
No branches.
Everything always goes onto the trunk and gets merged. And if there's a problem, you know about it instantly. You have more, and that means you have more problems per day because you have little tiny things, and you go in. Oh man, this change. Oh, this change. This change. This change. So you have lots of little paper cuts instead of cutting off your arm once every few days. And I prefer paper cuts myself. So but we'll see how that works out. We have a great question from Geraldine. Hi, Geraldine. Very nice to see you here. And so she says, we have CI, not yet fully CD, but we are still so slow. Devs still do these really big commits. Any hints for how to encourage small, frequent commits? So I have my own thoughts. Jeffrey, do you want to jump in first, or should I go?
Measure and make a big visible chart of the number of commits per day per person.
That would certainly be one way to reinforce the culture.
Start by making it visible.
Yeah.
And then when people aren't committing, you can ask, ask for an account? We've talked about it. We want frequent commits. How come you didn't have anything to commit yesterday?
Indeed. And I've actually had great success with teams actually. And I've asked, what have you released to production today? And often at the beginning, the answer is no, nothing. If you ask the question over and over again, people start to say, well, really, you want me? I mean, I'd like to say something. And you say, yeah, what's stopping you? Well, I have this big branch. Well, how about if you stop branching? Whoa, okay, well, that would be strange. All right. And then they start to get the message. And then people start to say, well, I released this yesterday. I released that today. And you start to get the message. So I think those cultural levers are really important.
I like yours better, by the way. And I'll say that because you're dealing with what the outcome, which is you actually want. I do something similar. Like the daily stand-up, we'd say, what do we have to demo today in production? Then there's what made it to production. If the answer is nothing, it's like, well, and people might say, oh, I have this change locally. I'm like, well, let me know when we can demo it.
Yeah. Let me know when you actually finished it. Because you haven't finished it.
I can show it off my desktop. No. Demos are for production.
Yep. And that is a mindset shift, which an attitude shift, which you, Geraldine, might reinforce. And you're going to need to reinforce it a lot. People will need to hear it multiple times before they believe it. But over time, that really does work. The other thing I'll note, and I think it's much less valuable, but it is the sort of thing you can do, is to do stuff technically to stop branching. So you can do things that more or less enforce, I won't release something off a branch. I won't let you merge. So you could really kind of outlaw some of the practices. Now, the problem is if you just do that, you won't change the culture and people will find other ways to sneak around it. So I think it's much more important to make the cultural change and get across the message. This is how we do things. This is the benefit. We're going to be releasing whatever target you have once, twice, 50 times a day. Then over time, you'll get the technical practices backing that up as well.
And it can help if you have someone who in development, a developer who's willing to run the experiment. Can you try running this experiment of committing after every time you get something done?
Yep. That sounds weird, but I'll try it. You want the person who would say
look, it's math. Look, if you're committing every day, if you're committing multiple times a day, if you're committing 4 times a day, you're making the merge problem someone else's problem. Never spend your time merging again. Make the other people merge with you. And when people start having the actual benefit for themselves in their normal workflow, then it gets much more exciting.
There you go. So Guillaume asks a related question here. Hi, Guillaume. Very nice to see you here. Is trunk-based development the best way for CI? So if I were PJ, and I think I agree with PJ, I would say it's the only way. If you're doing this merge stuff, you're not continuously integrating. You have somebody who's kind of going off away from the main practice and who's, I'm off here on my branch, doing my extra thing. And there are people, of course, teams that institutionalize this. Every single change goes on a branch. So you have not just one branch, but many, 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 many branches. It looks like a menorah or something, it's way out here with so many branches. And when they do that, they're not continuously integrating. They may be using a continuous integration server. They may be getting some of the benefits of eventually merging and testing these things. That's a good thing. Don't stop doing that. But the problem is you're not really continuously integrating. So I think I'd say you certainly should give it a try. I think it might move you a lot closer to where you'd like to be if your goal is rapid response. And I think, Guillaume, in your environment where you're dealing with an awful lot of people, and if I remember right, you're dealing with their pets. So you've got individual users who really want to service their needs. So you could be releasing many, many times a day, I should think, in your situation. You're not building a nuclear plant. So hope that's helpful to Guillaume. Great. Geraldine says, yes, I've asked them to do the experiment with me. Don't know if they will accept yet. Let's see. Excellent. Well, Geraldine, let us know. Come on the Squirrel Squadron forum, by the way, which is where one of the links to the recording of this will be. You can come on there and let us know how that works. Very happy to talk with you more about how that experiment goes.
Ask people how much time are you spending merging? And the person who can say I spend no time merging. It's like, okay, great.
That's what we want to hear. We had a question early on, and I hope George is still here, but I thought it was a great question for later on. George was really anticipating later stuff. What George says is, it sounds like it would be particularly relevant for software that includes ML, machine learning, and is self-evolving constantly. Now, I think that would be fascinating, especially for the kinds of things we were talking about with monitoring in production. What actual results are you getting when the computer is essentially writing your code, so you don't know actually how it works or what results it's going to get, and you're changing and updating it? I sure would want to monitor that in production, wouldn't you, Jeffrey?
Yeah, absolutely. And it's a good point. And this is, I think, I think there's an emerging term called data engineering, which is or data science engineering, which is trying to bring some of the practices from engineering to data scientists. Historically, the development practices among data scientists were poor. And they had very little control. They had a lot of intermediate work products that were essential for the end product that were not being versioned and would often be lost. So I think there's been a lot of work. A lot of places have realized this, and they said, okay, look, we need to keep all the products that we depend on for our end result. So in the case here, where we have a model that we're building, we're training this model. It's not enough just to have the code that is behind it or the data that's behind it. We actually want to save the model output itself as well, and as an example. So I think I definitely agree.
Yep. And I see this whole area of data engineering, data science. We have our earlier live streams on these topics, by the way, if you want to go back in the history and find them or look on the forum. But this area is very, very new. And a lot of the good practices we built up, say, in the last 20 years, thanks to your work, for example, Jeffrey, those are kind of making their way into the data world. Yes, George, I definitely agree. This would be a very good set of practices for our ML friends to use, and I'm not sure they've heard of them. So I hope we're doing something to address that. And maybe you can tell some of our machine learning friends, hey, there's this crazy idea where you actually could version everything you do, and you could make sure that it all works together, and then we could actually test it in production, and we'd know whether the model you just changed breaks our entire business model. That would be great. So if you do that, please let us know how that works out, George. Good stuff. So I don't see any other questions, and I'm just going to invite people to throw in a question if you have a late one. Would be very happy to help you with that. But I just want to mention some more things about the Squirrel Squadron. So there are events like this every week at about this time. We have another one next week, which is for the executive members of the community. It's a Zoom call with a little more interaction, and that's going to be on cadence and getting your team to go fast. We've talked about releasing fast, but how about other things that you could speed up? How could you get your team moving quickly? Then the week after that is a live event in London. So for those of you in London, welcome to come along and talk about helping your technology team to be bold. And I'm going to be working with everybody together in person, finally, after a long, long time. Glad to see everyone again. So how can your tech team be bolder? How can you get them to do the equivalent of jumping out of a plane with a parachute, but trying new things and being more daring? And then we're going to talk about, gosh, I'm trying to remember what else is coming after that. What we're doing after, I have to look. Remind myself, estimation beyond specifications and no code, how to do software without engineers. So lots of exciting stuff coming. You can sign up at, let's get the right place and I'll put it up here. And I'll type it in correctly. That's SquirrelSquadron.com, which I can get on the screen. There we go. And would love to see you there. There's also, as I have mentioned, a forum in which we are discussing many of these topics and many others besides. So glad to have you here. I don't see any more questions. No, just mostly people saying thanks. So glad we were able to help, and would love to hear from you on the forum, on the squadron, any place else, and would love to see you at a future event. And thank you so much, Jeffrey. Really appreciate you coming along, telling us some stories.
Thanks for having me. It was a lot of fun.
Absolutely. Take care. Thanks, everybody. Have a great day.